All right, so trig fundamental identities. The identity thief. Take really, really good notes on this, okay? So the basic trig identities, which we've already kind of talked about. First, a trig identity is an equation involving trig functions that is true for all values. So no matter what you plug in for the angle, it will remain true for all of them. And they can help to evaluate functions, simplify expression, prove identities, and solve equations. And they are used a lot in calculus, okay? So let's just think about our right triangle that we have. So when you have to do trigonometry in math class, SOHCAHTOA, that literally never goes away. If you remember anything from trig, remember SOHCAHTOA. But, so we know like sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent is opposite over adjacent. Okay, so then what if we put sine over cosine? Well, sine over cosine, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then those hypotenuses cancel out, and I can kind of show you why. I mean, we've talked about it a little bit, but if we go from here, if we have opposite over hypotenuse, a fraction really just means they're being divided, so that's divided by adjacent over hypotenuse, which then I can flip this, and I get opposite over hypotenuse equals, or not equals, my bad, times hypotenuse over adjacent, and the hypotenuses cancel, and I'm left with opposite over adjacent. Okay, so that's why, or you could literally just go like right here and just cancel the hypotenuse because they have the same thing on top and bottom, and you end up at opposite over adjacent. Okay, so then we have that, which opposite over adjacent is just tangent. So that means that, and we've already kind of talked about this when we were doing the unit circle. So that means that tangent is sine over cosine. Okay, where cosine can't be 0 because you can't divide by 0. Okay, and then we also have the functions cosecant, secant, and cotangent. And we've learned that those are reciprocals because cosecant's hypotenuse over opposite, secant's hypotenuse over adjacent, cotangent's adjacent over opposite. So those are called the reciprocal identities. So sine is 1 over cosecant, cosine is 1 over secant, tangent is 1 over cotangent, cosecant is 1 over sine, secant's 1 over cosine, cotangent is 1 over tangent. These are all things that you need to know. I will give you a paper with all of them. It is still a good idea to write them down though, okay? And the other one, so if I know that cotangent is 1 over tangent, that just means I could flip the tangent for the quotient identities, and cotangent is also cosine over sine. Okay? Now let's use those. So if secant is negative square root of 3, or square root of 30 over 3, we want to find cosine. Well, I know that cosine and secant are reciprocals, so I can really just flip it. Like, you get mad and flip your desk. I've never done that. Like, I've talked about it. Like, I play games with my brothers or whatever, and it's like, I want to flip the table over. Anyways, okay. So cosine is, I could just flip that fraction. So that's going to be negative 3 over the square root of 30. We don't like that square root in the bottom, so I'm going to change it, get rid of it. So I multiply by square root of 30 to top and bottom. Get negative square root of 30 over 30, which is negative square root of 30 over 10. Okay, and so cosine equals negative square root of 30 over 10. Let's do this one. So if tangent of x equals square root of 2 over 4, and cosine of x equals negative 2 square root of 2 over 3, we want to find sine of x. So we need to look and figure out what am I going to use. Like tangent of x, well, I know tangent is the reciprocal, cotangent, that doesn't help me, but I also know that tangent is sine over cosine, so I'm going to use that quotient identity up there, which I can just rearrange this equation to get sine by itself, so I'm going to multiply by cosine to both sides, and I get cosine of x times tangent of x equals sine of x. Okay, so I just moved it around a little bit, which I know what cosine of x is. It's negative 2 square root of 2 over 3. I also know what tangent of x is. It's square root of 2 over 4. So I can just multiply those. I get negative 2 times 2 over 12, which is negative 4 over 12. So sine of x equals negative 1/3. Okay? Boom, shakalaka. Let's do another. So if cosecant of that symbol right there is beta, so this right here, everyone gets these mixed up. So this is theta with a TH, and this is beta. Okay, they're just Greek symbols that are used a lot. They're mostly used for angles. Okay, so if cosecant of beta is 7/3 and cotangent of beta is -2 square roots of 10/3, and we need to find secant. So like, what should we do here? Well, let's see. So first, let's get cosecant to be sine. So I know 1 over cosecant is sine, so I can just flip that, and that's going to be 3/7. And I also know that 1 over cosine is secant. So, and I know that cotangent here uses sine and cosine. So let's use that first to figure out what cosine is. So I have cotangent of beta is cosine of beta over sine of beta. If I multiply by that sine of beta to both sides, I get sine of beta times cotangent of beta equals cosine of beta. And I know what sine and cotangent are, so I can plug those in. So I have 3/7 times -2 square roots of 10/3, which simplifies to be -2 square roots of 10/7 is cosine. But I'm still, that's not what I want, right? I'm finding secant, but I needed to find cosine in order to find secant. So then I'm going to do 1 over cosine equals secant, so I can just flip it again. And I get -7 over 2 square roots of 10. Rationalize it, multiply by the square root of 10, and I get -7 square roots of 10 over 2 times 10, which is -7 square roots of 10 over 20. Okay, that was kind of a lot, but like really it wasn't that bad, right? We're just like kind of messing with things. We're moving fractions around. I believe in you guys. I think you're all super smart, so we can do this, okay? All right, Pythagorean identities. These are so important. They're so important. You need to write this down. Okay, every time I've talked to the calculus teachers, like what trig stuff do they need to remember? This is like the biggest thing that they say, okay? This is so important. Okay, so if we have just our right triangle, because Pythagorean, we know that that's a squared plus b squared equals c squared. All right, well, so let's just divide both sides by c squared, okay? Because I want to get this equal to 1. So then I have a over c squared plus b over c squared, and c squared over c squared equals 1. Okay, all right, hopefully we're all okay with that. Now, I'm going to put the angle right there, okay? And then I know that we're back to SOHCAHTOA. Don't get me started about the education system. Yeah, and I'm a teacher, and I love teaching, and I love the thought of what could be, but I also think that, never mind. Okay, so sine of theta is a over c from SOHCAHTOA. Cosine of theta is b over c, and tangent is a over b. Well, we have this a over c right there, and we also have a b over c. So that's going to be sine of theta squared plus cosine of theta squared equals 1, which whenever you square like a sine or a cosine, you can just rewrite it like that. So sine squared of theta, that's the same as saying sine of theta squared, or cosine squared of theta equals 1. This is our first Pythagorean identity. Okay, and probably one of the most important ones. Like, you need to remember that sine squared plus cosine squared equals 1. Okay? So let's go back to a squared plus b squared equals c squared. And instead of dividing by c squared, let's divide by a squared. So we're going to get 1 plus b over a squared equals c over a squared, which we don't have a b over a, we don't have a c over a, but if I do my reciprocals, we do. So cosecant is c over a, secant is c over b, and cotangent is b over a. So then that's going to be 1 plus cotangent squared, because b over a is cotangent, and c over a is cosecant. So that's going to be 1 plus cotangent squared equals cosecant squared. That is the second Pythagorean identity that you need to remember. Okay, and then the last one, now instead of dividing by c, let's divide by b. So I'm going to divide both sides, or everything by b squared. And I get a over b squared plus 1 equals c over b squared, which a over b is tangent, and c over b is secant. So then we get tangent squared of theta plus 1 equals secant squared of theta. Those are the 3 Pythagorean identities that are so important to remember. And if you just remember that Pythagorean means a squared plus b squared equals c squared, you could derive all of these. Okay? So there are those Pythagorean identities. Make sure to have them written down. And then let's use them to find these values. So if we want to find cosine and we want to find tangent, if sine is negative 1/3 and cotangent is less than 0. So cotangent, all this is saying right here is that cotangent is negative. And since cotangent and tangent are reciprocals, that also means that tangent is negative. Okay, so whatever we get, this is going to be negative. Okay, so then here we have sine of theta, and we're trying to find cosine first, which means I'm going to use this sine squared plus cosine squared equals 1. So that's going to be negative 1/3 squared plus cosine squared equals 1, which negative 1/3 squared, if you square both top and bottom, that's going to be 1/9 plus cosine squared equals 1. Subtract that 1/9 and you get cosine squared equals 8/9. Square root both sides, and you get cosine equals the square root of 8 over the square root of 9, which the square root of 8 is 2 squared, so 2, and the square root of 9 is 3. So cosine of theta equals 2 squared to 2 over 3. Cool. And now let's find tangent. And I'm going to use that tangent squared plus 1 equals secant squared, which if I know cosine, let's just flip it, and we get 3 over 2 squared to 2. And I am not going to rationalize this because since we square it up here, right here, since we're just squaring it, the square root is going to go away. Bye-bye. Okay, so I'm just not going to worry about rationalizing this. So then here, let's plug in what we know. So tangent squared plus 1 equals 3 over 2 squared to 2 squared. And then that equals tangent squared plus 1. 3 squared is 9. 2 squared to 2 squared. When you square this, so if I have 2, what is going on? 2 squared to 2 and square it. That's the same as 2 squared times the square root of 2 squared, which is 4 times 2, which is 8. Okay. So then I'm going to subtract the 1 over. I get 1/8. Square root both sides, and I get the square root of 1 over the square root of 8, which is 1 over 2 squared to 2. Rationalize it, so multiply by square root of 2 to top and bottom, and that's square root of 2 over 4. But, and I forgot this, so remember that cotangent is negative, which means tangent is negative, so this, and whenever you take a square root, it's plus or minus. And so our answer here is tangent of theta equals negative square root of 2 over 4. Okay, and over here, if they don't tell you, just assume the positive. But like they told us this, and so that's where we know, okay, this has to be negative. Okay. Okay, cofunction and even and odd identities. So the cofunction identities, that's like sine of theta equals cosine of pi minus 2, which is the same as 90 minus theta. And I'm just going to pull up the graphs. So if I graph sine of theta, it looks like that. If I graph cosine of theta, they look the exact same because they are the exact same, okay? That's the same with cosine of theta and sine of pi over 2 minus theta. Same exact graph. Same with tangent and cotangent. And cotangent and tangent. You can do this with all of them, okay? Secant and cosecant, and cosecant and secant. So think about these names right here. So we have sine and cosine, sine and cosine. We have tangent, and we have cotangent, and we have secant, and we have cosecant. Okay, this co means that they are co-functions. So sine and cosine are really the same graph, you just have to move it a little bit. Same with tangent and cotangent, same with secant and cosecant. Okay, they are co-functions. Okay, and we also have even odd identities. So we have sine of theta is the same as negative sine of theta, which makes that an odd function. So odd functions mean that if I was to flip this all the way around, it looks the exact same. Okay, and I will try and go through this a little faster because this is taking a long time. Cosine of negative theta is the same as cosine of theta, so that one is an even function. Tangent of negative theta is the same as negative tangent of theta. Cosecant negative theta is the same as negative cosecant. Secant negative theta is the same as secant, and then cotangent of negative theta is the same as negative cotangent. Cosine and secant are the only ones that don't keep the negative. Okay, these ones keep the negative. So let's use these a little bit. So if we have, almost done, I promise. So if we have sine of negative theta equals negative 0.97, and we want to find cosine of pi over 2 minus theta. Well, first, I know that sine of negative theta is negative sine of theta, which means that negative sine of theta equals negative 0.09, or 0.97. So if I have negative sine of theta equals negative 0.97, that means that sine of theta equals 0.97, because I could just divide both sides here by negative 1. Okay, but then that's not what we're trying to find. We're trying to find cosine of pi minus 2 over minus theta, which that is just sine. So that means that 0.97 equals sine of theta, which equals cosine of pi minus 2 minus theta. So cosine of pi minus 2 minus theta is 0.97. Okay, so tangent of negative alpha, that little symbol is alpha, equals negative 2.36. We want to find cotangent. So I know that tangent of negative alpha is the same as negative tangent of alpha. So kind of the same as before. That's going to equal 2.36. And then if I want to find cotangent, well, we have to do a little manipulating here, because notice these are flipped. Like on this one, it's pi minus 2 minus theta, and this one is alpha minus pi minus 2. Or pi over 2, sorry, I said that wrong. So let's just manipulate this a little bit. Yep. So let's look at this cosine of alpha minus 2. So if I look right here. Sorry, I think I should write this down, actually. So this tells us that cotangent of negative theta is the same as negative cotangent of theta. So if I do cotangent of negative alpha minus pi halves, that equals negative cotangent of alpha minus pi halves. Okay. So then here, I can distribute this into here. So I get cotangent of negative alpha plus pi halves, which I can just rewrite as cotangent of pi halves minus alpha. Okay, which is what I wanted up here. But that equals negative cotangent of alpha minus pi halves. Okay, which is what we have right here. So if I'm trying to find tangent, I know that cotangent of pi halves minus alpha is equal to the negative cotangent of alpha minus pi halves. But I also know that cotangent of pi halves minus alpha is equal to tangent. right? Which I have tangent. So I'm just going to plug that in right here. So I have 2.36 is equal to negative cotangent of alpha minus pi halves, which that's almost what I'm trying to get, but we have this negative, this pesky negative. I'm just going to move it to the other side. So negative 2.36 is the same as cotangent of alpha minus pi halves. Okay? So this is, I did that work, and you get 2.36. All right, that's it. Bye, guys. Maybe.